Hey everybody. So in this video, we are looking at double and half angle identities. So in this problem, it says if tangent of theta is 21 over 20 and theta is in between pi and 3 pi halves, find cosine of theta over 2. So this is a half angle identity. Well, the first thing that we want to do is figure out where our reference angle is. So they told us that theta here is in between pi and 3 pi halves. Well, remember, that's referencing the unit circle. So we know that on the unit circle, we start at 0 and we end at 2 pi. This is pi over 2, pi, and 3 pi halves. So if our reference angle is in between pi and 3 pi halves, then we are here, pi and 3 pi halves. We're in quadrant 3. So if I drew a triangle in quadrant 3, it would look something like this. There's my reference angle in my triangle. Now, we use this with the trig ratio they gave us. Tangent of theta is 21 over 20. Okay, this is very helpful because we know tangent is the opposite leg over the adjacent leg. So if I look here at my reference angle, the opposite leg is going to be 21, and the adjacent leg here is going to be 20. Now, one thing to remember is the value of the legs in this quadrant. Imagine that this point here is a coordinate point. In order to get to this coordinate point, starting at the origin, I had to go to the left 20. So that means that this x value should be negative. And then I had to go down 21. So this y value should be negative. Now, that can be strange because you look at this and you say, whoa, 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 I have negatives here. Tangent is positive. Well, tangent's the opposite over the adjacent. What's negative 21 over negative 20? Well, a negative over a negative is positive. That's why the ratio here is positive. This is why when you learn quadrant, the values of trig ratios in quadrants, tangent is positive here because a negative y over a negative x gives you a positive value. Now, they ask us to find cosine of theta over 2. Okay, well, we need to do a little bit of thinking here. Cosine of theta over 2. One, let's see what they're asking for. So the formula here is plus or minus the square root of 1 plus cosine theta, and this will all be over 2. Now, I need the ratio for cosine theta in order to answer this question. I can't use cosine until I know what this hypotenuse is, because cosine requires the adjacent leg and the hypotenuse. I have the adjacent, I do not have the hypotenuse. So I'm going to need to find that. So we'll use Pythagorean's theorem here, and that is negative 20 squared plus negative 21 squared. This should equal c squared. So 20 squared is 400. 21 squared is 441. So that means 841 is the value of c squared. So if I want the hypotenuse, I need to take the square root. So I'll take the square root of 841, and that's going to give me 29. Now, one thing here, this hypotenuse is never going to be negative. The reason for that is this hypotenuse is the distance from this point to the origin. The way you find the hypotenuse is a squared plus b squared equals c squared. So anything squared is always positive, and if you add two positives, you have to get another positive value. So this can never be negative, and it doesn't matter what quadrant you're in. So cosine of theta here is going to be the adjacent negative 20 over 29. So here we have plus or minus the square root of 1 minus 20 over 29, and this will all be over 2. All right, I'm going to just enlarge this square root sign a little bit. Okay, there we go. Now, I'm just showing you that all of this is underneath the radical here. Okay? Here, this isn't going to be too bad. Because even though that it's 1 minus this fraction, 1 is the easiest number to subtract fractions with because you can rewrite 1 an infinite number of ways. So in order to subtract fractions, we know we have to have common denominators. So instead of 1 here, I could just make this 29 over 29. So here I could say this is 29 over 29. Now look, common denominators. So here, 29 minus 20 is just going to be 9. So we have the square root of 9 over 29 divided by 2. So here what I did was I just went from this traditional, this index fraction format, and I just went to this traditional format where I could say 9 over 29 divided by 2. Now we know that here, when you say divide by 2, this is the same thing as multiplying by 1/2. So what I'll do is I'll come down here real quick and we'll write this out so we can say 9 over 29 times 1/2. So this is going to give us 9 over 58. So this is the square root, plus or minus the square root of 9 over 58. All right, from here you can just put this into your calculator. So if I have the square root of 9 and I divide that by the square root of 58, that's going to give me, once I rationalize, 3 root 58 all over 58. The way you got this answer from here, when you have a fraction inside of the square root, you have to take the square root of the numerator and the denominator. So we know the square root of 9 is 3, and the square root of 58 is just the square root of 58. But we can't have square roots in the denominator, so we rationalize. So we bring that root 58 up, and we get rid of the root 58 on the bottom, and the square root goes away. Now, here, this means plus or minus. So this answer can't be positive or negative. We need to know whether this solution is positive or negative. So the easiest thing to do here is to look at our domain. So we have pi. The domain is in between pi and 3 pi halves. So if we took that and cut it in half, then pi divided by 2 is pi halves. 3 pi halves divided by 2 is 3 pi fourths. So this puts us in between, it puts us in quadrant 2. So cosine is negative in quadrant 2. So this would be negative 3 root 58 all over 58. All right, that's going to be it for this video. I hope that you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.